Welcome to the lecture series on object oriented analysis and design. The most difficult idea is to identify the objects. What are the objects? How do they become obvious? Once the objects become obvious, which are the set of objects that need to be put together to make me do a particular task? By saying so, I am not trying to indicate that this is the only method or this should be the only method. Where the task is so clearly defined, this is proving to be very productive, very efficient, able to build more things. The idea is very good. In the last lecture, we have been talking about Meccano. There are a set of components that you can always decide. First, make them happen. Using these components, metallic components were there, they have to be, it's like really doing an experiment with nuts and bolts. So, using the nuts, using the bolts, using these metallic components, you can prepare a few things. Certain things are already known to be done. You are welcome to use your creativity, put different combination of the things, maybe you will produce some other artifact which is not there in the list of things planned, or if you get few more components which can be connected, you may do better. Extensibility is there, gradual building is there. However, how do I know what are those components with which I can do 20 things, 30 things, 40 things? That is a difficulty, that is a question mark, and that is where we need to step in to find out what are those generic components. Another example is our integrated chips. There are only few integrated chips, but using these few integrated chips and few electronic components, you see how many millions of circuits are happening. Now, we say that it is not only putting together the components, there is a good theory, circuit theory, which is telling that these components will interact like this, only then the circuit will behave like what you have been planning or designing or talking about. So, only few electronic components, few integrated chips, when we are putting together, we are getting so many circuits. So, in summary, we can always tell that the idea of light bulb is very generic, the idea of a light holder is very generic, the wire is generic, the switch is generic, the way we operate is generic. It is just that different brands. So, using these four components, you are able to create so many things that you yourself will puzzle if there was no way in which we can decide that only these components can be connected to do what we are working, it would have been next to impossible to understand this idea. In the field of hardware, it becomes easier because the hardware itself tells you, you can't do more than this. It has a limitation, it has a dialogue. In the field of software, we have always been finding it difficult. We normally tell that hardware is a more matured field in this idea. It tells for itself. I know for sure that this entire monitor, I cannot possibly keep it under the mouse and do the same thing to get an effect. It does not, it is not, even though the task is clear, it is not giving the same effect, it becomes very clear to us. Or this keyboard, I cannot keep it at the corner of the room and run around to operate the keyboard. So, what we understand here is that the hardware field is more mature. There is so much maturity that it will tell you that this can happen, this cannot happen. Whereas, in the case of software, nothing is impossible, or our strength as well as our weakness is that plasticity. Anything can be changed, anytime we can change it, we can always keep thinking that the next change is the magic solution, but then such things did not happen. So, in the quest for having a way of working with this idea in the field of software, we started talking about object oriented analysis and design as perhaps the next best bet by 90s. However, the most difficult aspect is what we are discussing right now, namely the object identification. Anything is an object, anything can be called an object, we can have any number of objects, but for what? So, the moment we started latching on to this idea called object as the next cash cow, everybody wanted to introduce that term object. It happens in the way we work. So, object is the most used and abused word in the world of computing today. There are many things in software, many things in computing science which do not really have that exacting definitions to tell that this is only this, exactly this. The other sciences, the other human endeavors have very definitive way of telling that this can be called object, this cannot be called object. We do not have that luxury. As a matter of fact, the debate goes on, how much science is there, how much engineering is there science, is there engineering, or we are simply trying to make sure that the device that we have created and called it a computer, we want to make some return on investment, we want to progress further, we want to make it functional, because it shows some advantages, it takes away the drudgery of doing the mundane chores, and hopefully if that is taken away, we will use the human intellect for doing better things, more complex exercises. Well, whether it is achieving or not, whether the computing is taking away our capabilities, these are all debates that will keep on happening. So, there is no definitive reason to believe that this is how object will be. In the absence of such a definition saying that this is an object, whereas in other fields, whichever field you take, a component has an exacting definition. Nobody can dispute that, it is defined like that. Whereas here we still have some leeway to talk, to deliberate. This is the end goal of all computing, problem solving. So, from problem solving we have moved over to program engineering. From program engineering we started talking about software engineering with a kind of an anticipation for what next. This is done, this problem is done, it has been taken away from the context, it has been expressed differently, it has found a way of reaching to the machine. Now, within this what is happening? This input case is working, this input case is not working. Can I anticipate? Can I anticipate the next? So, we started talking about all these things from program engineering to software engineering. This happened in 68, 69, we need that. We need that kind of a definition. Otherwise, what happens? One big program is succeeding, nothing else is able to emulate. So, there must be some way in which we can make that genericity, that idea of abstraction deliver in so many other applications. Towards that we built the field of software engineering. Yes, it is true, Unix was a roaring success, but how many in that decade had been at least called somewhere comparable success? Did not happen. So, we keep saying the same thing, that the idea of abstraction has been always powerful. Human endeavor progressed rapidly because we know how to abstract. However, the success of building things on abstraction in the field of computer science and engineering needs next step. Outside of program engineering, we need software engineering. Traditional approach, dissect any problem into its simpler components, build the simpler components. Now, it is lot more easier. You see, we keep talking about a simple story, that is the Columbus egg. The king of Spain created one competition asking people to make commitments that they set sails and find India. He was interested, he wanted to find where India is. A team led by Columbus won in many cases. They had some parameters, the king of Spain had a list of parameters, and this particular team led by Christopher Columbus has won the money bag that will enable them to take on this adventure. So, they went on an adventure, they came back, and then they said that what we found was America. But still, nevertheless, the king of Spain simply said that we will have a dinner, banquet dinner in honor of Columbus. People were not so contented, because at the time when the competition was held and then result declared, the winner declared, the winning team went on its expedition and came back on an adventure, it was a different goal. They came back doing something else. Invariably, we keep talking about software and software development like that. We aim at something, we are roughly around 40 to 50% most of the times, and then we think that time up, cost is becoming prohibitively expensive, let us get on using it, it is a working solution, with reasonable assurance we will move further. If any major problems are occurring, we will create next version. That is how we have progressed. So, coming back to the story of Christopher Columbus, people were not so contented because they set out with one goal, ended up with one result, and then still the king is praising them. So, what the king said was people were not so enthused, and therefore, he wanted to give one more puzzle, saying that there is an egg, can anyone make it stand on one of its edges, the narrow edge of the egg on this table. People came, people tried, the egg is not standing, it is a dinner table, there are a lot of eggs, they tried, none of the eggs was standing on any of the edge. So, invariably the king was looking at Columbus, because it's in his honor a banquet has been made and organized. So, Columbus came, he thought for a while, he picked up some salt, put it on the table, made the egg stand on one of the narrow edge with the salt giving the support. Well, they said no, it was not allowed, there was no such thing. At the same time, there is no such rule that it is not to be allowed. So, when we talk about so many things, later on we talk about domain, we talk about expert systems, rule based expert systems, we are not at all comprehensively framing the rules. We can challenge on the rule only if it is there and defined well. If there is no such rule barring, it is still a rule permitting. So, we keep talking about logic, we keep talking about making so many things which are comprehensive. So, dissect any problem into simpler components is a very easy statement. See how nicely the task has been accomplished. There are so many things, so many people tried, so many people failed. Somebody who had a focus on the task, they did something which is all right, which is acceptable. If the king was finding it not acceptable, things would have been different perhaps. With hindsight, we can create 3 more stories what could have happened, but then it is easy to tell, dissect any problem into its simpler components. Easy to look at the Meccano and tell that these are the components from which 30 different items are going to be done properly as a hobby. We used to have a competition, who will rig it fast. We used to give a number to each of that artifact, pick a lot. Number 21 came, 21, what is the maximum time taken so far, can you beat that time? It is nice summer game, 1 or 2 summers, you will feel enthused about it. Build the simpler components first, that is an advantage. Whether the big software is happening 40%, 50%, we planned so much, we are giving so much, the commercials about building software are nicer now, because once you know which are the simpler components, you can build the simpler components easily. So, we can progress better, we will hopefully deliver 60% of the software within the given within the time or within the cost. So, we often do this exercise thinking that it is possible to identify the simpler components. It is always true, when somebody else has solved the problem, you feel very happy. You are not thinking about it, you are not solving about it, somebody else has solved the problem, but then while solving the problem, identifying those simpler components called objects or classes is going to be a very difficult exercise. But then once you identify, you tend towards what we called object oriented happiness. You found some simpler components, you are able to build them. What is the problem in this method? In this method, we keep telling that we build components, we do not know where they are, we do not know why we have built some components. In other words, how to put them together to show that yes, we have attained the original goal, original functionality, that is a bigger concern also. One is to identify simpler components, this may hopefully happen in our top down approach. A good number of components will become crystallized, we will start getting the work rolled out. Putting them together, what do we do? How do we make that happen? We are very good in analysis, but we are not so good in design. Design walked in very late, we will come to that later. So, this entire idea of object orientation is a new way of thinking. It is not the same old method. We have to somehow adjust, get accustomed, learn, become an expert in this new way of thinking. Therefore, we created a paradigm not to throw away the existing paradigms, they are all there, we have built many things on that existing paradigm, but then by creating a set of terms, terminologies, a way of working in object oriented paradigm, we are able to get the focus of the people into this paradigm. There is no way in which we can waver out of this. We draw lessons, we draw ideas from our earlier experiences. It is 2 decades, 3 decades of experience, and also object oriented itself was in cold storage for nearly 4 decades. It inherently permits both dissection and integration. As you do the analysis, you will pick those things which are integratable. That is a simple component. You can do lot of things. Suddenly, if you want to prepare something called electronics lab, so many things can happen. How do you pare down to the components? As you keep doing the top down analysis, the choices you make as to what to retain will tell what you can build back further. It can happen in parallel. Relates easily to the way we perceive the real world, and that is exactly what was the earlier lecture. It is no more the case of top down versus bottom up. It is top down and also bottom up happening in a judicious manner. That is the first advantage we got when we shifted everything to an object oriented paradigm, which is different, is distinct from what the structured paradigm was. It relates easily to the way we perceive the real world. You can always argue the same thing, saying that, for example, we have good colleagues of mine who are helping me do things. I was only focusing on how to get started. Everything else was happening by my side, but it does not bother me. I am not bothered. They are also not bothered about what I am thinking. I was doing my own task of setting out the things right to my satisfaction, so that the lecture will go on. It was nicely set, not much of work for me, but as I come, I need to understand that this is what it is, the camera, I have to get adjusted, things that make me feel at ease, that I will be focusing on the lecture. The other gentleman who was looking at the light adjustment, microphone adjustment, everything is happening in concurrence. In a concurrent mode, at least 4 or 5 different tasks were happening before this lecture began, but I was focusing only on this lecture. This was going on in my mind, and it is moving ahead. So, by doing all this, we showed another great improvement, that is, we are able to reduce the coding time and increase the design time. One of the errors which we found with retrospect, or with hindsight we became wise, is rushing into coding remains the number one problem in software development. Whenever we rushed into doing coding, we were always hitting the wall and we were having terrible results. This is true even for a 3-hour problem, this is true for a 3-year problem. Rushing into coding is not at all considered any practice at all. However, we are not able to, in our traditional approach for system development, software system development, we were not able to take away the focus on coding for a long time, until object oriented came. Once the object oriented came, we are able to stretch more on the design, reduce the coding time, but that took 20 years of development. So, we see pluses, but that is still not the magic solution, that is still not the silver bullet. It is still more hard work to do, but then what we have come up with is a very clear definition of a paradigm which will enable us to do reusability, easier maintenance, rapid development, improved productivity. That is what I am telling you. In the given time, in the earlier method, if we were able to do 40%, we are now hoping to do 60%. Seamless in development, the development can be seen obviously, we do not have to wait until somebody says, now come on, let us knit all of them together. We know what is knittable straight away. As we do the component identification, we know what else can happen. It becomes very obvious. So, the example of a bicycle, in the earlier world we were looking at it like this. Now, what are we doing? We are putting all these together in an object. All that one needs to know is a feel for how to bicycle. All these things will still be happening, gears are there, materials are there, wheel size is there, just get on with the task of riding the bicycle. How is this happening? With that new terminology which we have been discussing, classes, inheritance, polymorphism, cohesion, coupling, we said communication, reusability. With this kind of a terminology, we got a very nice way of talking about associations, aggregations, generalizations. Next set of slides we will see that. Then we can build further associations, aggregation, generalization. All these things simply mean that we have to now talk about a completely different way of thinking about software engineering called object oriented software engineering. To deliver quality software on time and within the estimated budget, that remains the goal of software engineering from day one. 1968, this was the goal. So, what is the difference here? The difference here is the specification can be incomplete, whereas for so many years we were hoping that there will be frozen requirements, so that the traditional model will work. It works best when there are frozen requirements. Now, with object oriented happening, as the specifications emerge, we do the analysis. As the analysis is happening, we can identify the components, we can keep building parallelly. It is a faster way of developing. It gets focused on to the higher phases without really bogged down in the higher phases. The lower phases, we know we do not have a way out. Once you get into the coding, it takes you further into the coding. Once you get into testing, it takes you further into testing. Object identification is the most difficult aspect. Optimization, orientation towards computing techniques. The design optimization is not readily visible as a computing technique here, because I do not see what is the computing that is going on in me positioning here, outside of the fact that is related to the objects. It associates to the objects that I want to use. I can be anywhere in the room. Why should I be here? There is a camera here, there are lights here, therefore, I am here. To do this lecture, there is no reason that I should be here. I can be anywhere. So, why is this place fixed? Because it is the optimal association with a set of other objects that are necessary for me to complete this lecture according to the way in which the lecture is happening. The regular classes, I can do this lecture without all these, I can walk around in the class, nothing happens. But then please understand that the context is getting spelt out in the way we are talking about how the objects are getting interrelated, which is a huge plus. We do not have to do another special exercise to bring back the context. Remember, in the beginning we said that the first instinct of computing is to knock away the context in the name of specifying the problem. Then the problem is also specified in a manner where it does not have much of a connection to the domain, it does not have much of a connection to the stakeholder. It is in that pristine abstract definition of a problem which all of us think is related to what we had in mind, but none of us will actually able to tell whether it is what we had in mind or not. Then we moved it over further, then we said it is also in a different language to get it more and more closer and closer to the machine. Object design is modeling. So, object identification is very difficult, that is analysis. Object design is modeling. So, when we are talking about object oriented analysis and design, we are talking about object identification and modeling. This is another way of telling the same thing about the course. Then we start about coding. Today what we have done, by the time object oriented analysis and design began to happen in large numbers and people got it as a big challenge, whether it has delivered as much as expected or not is not our concern, but the technology, it was a fascinating challenge for many. So, coding was necessary. We were able to condense the coding phase, increase the design phase as seen earlier. However, we did something more, we created what are called automatic code generators. Very specific to this course, later on in the subsequent lectures, we are going to do unified modeling language. So, all that we did so far, that is object identification, modeling, all the thing, object design, everything put together, we make it a unified model and express it in a set of diagrams which is called unified modeling language. After everything is specified in that unified modeling language, you have to simply choose a tool, click a button, tell that I want the code to be generated in C++. Next few minutes C++ code will come. Next few minutes if you have chosen Java, Java code will come. So, we think that automatic code generation will further reduce the effort on coding. In summary, the first success we met because of many reasons, not because we were debunking the existing methodology, because of a lot of experience that has gone behind. We do not relate software engineering exactly to coding. We do not want to relate it. Software engineering is much more, even program engineering is not coding, it is much more than coding. coding is a mechanical and a minor part. By the time OOAD began to tell its effect, coding was not considered such a serious and a fantastic idea. We need to do coding. Coding is inevitable, but then that can be done by automatic tools. However, we know for sure that whatever be the code we are talking about, only 33% can be tested, and even the code best of the programmers have written are likely to have one defect in every 10 lines. Automatic code generator is also a piece of software. Where things have become mission critical, we have to undergo the exercise of testing the code. It is not merely test case generation, where half a dozen cases or whatever boundary conditions are tested, but this code is to be tested in a manner where the automatic code generator will have to be ascertained whether it has gotten the unified modeling language correctly made into a Java code or a C++ code or whatever language you have chosen. So, we have begun to assert that software engineering or program engineering is certainly lot more than coding. Please do not confuse these two. Coding is necessary, but that coding is what we have understood is going to be pushed into the machine in a manner where the machine will execute. It is not doing anything more than that, it is executing that code, it is not doing much. So, it is a mechanical and a minor part. So, where is the time that we have to create for testing? Again, we did not want to increase the testing time. What advantage we got by reducing the coding time? We did not want to increase the testing time. See, this is a nice diagram which I showed, saying that a few slides back, which is like this: systems development. This is what it is. The testing phase remains the same. We do not want to increase the testing time at all. So, this also got lot of tooling, this also got lot of tooling. So, we think that if somebody can focus on object oriented analysis and design, the rest of the story is automated. Even if you want to take some more design time, we can make up for the lost coding time or testing time by taking recourse to those languages, standard syntax, and therefore automatic code generator. It is a good idea, we have been trying around, but we all know that an automatic code generator is likely to generate 40% more lines of code than what a typical programmer, an experienced programmer would write for the same problem. But we think that the time is saved. Then we started asking that question, if for 100 lines, a problem that I can solve in 100 lines, if the automatic code generator is taking 140 lines, there is a serious concern. Let us say 40% more lines, but then what we have done in the present day situation is that we are not at all concerned about optimizing on the memory. Memory has become very cheap. I have come across a generation of programmers who were struggling weeks, days, hours, where of decreasing time demands, days, hours, minutes to save 1 bit, 5 bits. Now, it is no more the case. We have plenty of memory to work with. We are not so much on optimizing the usage of memory, but then we should. Good disciplines of programming should talk about optimization. This design is more about optimizing on the memory, optimizing on the way in which the execution happens, the time taken. The typical optimization concerns must be kept in mind. Just because we are doing automatic coding, we cannot vitiate this law. Object design is modeling, and then we do testing. So, effectively the new paradigm has paved way for thinking about software engineering in a completely different manner. Again, I wish to repeat that this is also not a silver bullet. It is a nice idea. It has shown us that there are a wide variety of applications that will be done in a more impactful, efficient and effective manner by the people who are working on those problems as solutions will emerge. So, it is not that software engineering prefixed with OO is object oriented, it is a completely different way of solving problems. So, how are we solving the most difficult problem? That is object identification. There are 5 handful of methods: textual analysis, tangible entities in the application domain, behavioral analysis, scenario analysis, database approach. I am not going to spend time on what we have done yesterday, textual analysis, domain specialists, behavior analysis, the data flow diagrams. If we know how the data flows, by far we understand. I will pick up from the next lecture. To summarize, we have been talking about the progress of using object oriented as a separate paradigm, so that we can do better things, build software engineering in a more impactful and efficient manner, at least in those areas where it is feasible. So, that is a summary of this lecture. Thank you. We will meet again in the next lecture.